Welcome back. This is lesson 2 of week 21. In the previous lesson, you wrote the merge function which merges two lists. In this lesson, we'll talk about how we can use that function to create the merge sort. And in lesson 3, we'll actually program the merge sort. So in this lesson, I'm just going to talk about how the merge sort will work and think about its advantages, its disadvantages, the big O value, and briefly review some of the variations that we might write. But actually writing the code will be in lesson 3. You can watch these lessons, of course, in any order that you like. Last lesson, you wrote a Python program which included a merge function, and we're going to reuse that merge function. The merge function takes two sorted lists and makes one big sorted list. Now let's think about how we can use that to sort an unsorted list. The answer is that we split the list into lots and lots of little lists, and then we use the merge function that we've already written, of course. We use the merge function to merge all those lists back together in sorted order. In fact, we're going to split the list down into lots of little lists of one item each. So we begin with one unsorted list of n elements, like 100 or something. And after we've done all our splitting, we'll end up with 100 lists of one element each. And if you think about it, a list of one element is always a sorted list. It can't be out of order, can it? So we've ended up with lots and lots of tiny little sorted lists, and then we can merge them all back together again to end up with one big sorted list. First, we're going to merge all the lists with one item in, and then we'll have a lot of lists with 2 items. And then we'll merge them to have a lot of lists with 4 items, and so on. We keep merge, merge, merge until we end up with one big list, which is sorted. If you're my students, we'll act this out in class. And if you go on YouTube, you'll find some very charming videos of people dancing the merge sort. And another thing you could try would be to get a pack of cards and split it up into lots of little piles of one card each, and then merge them up to create a long sorted pack of cards. So here are some ways that you can explore it before we even start programming. So what's the big O value for the merge sort? To split a list down, chop a list in half and half again until it gets down to one item. Well, we already know how many operations that is, don't we? Because we used it in the binary search. We know it's log n operations. But we haven't finished there, of course. We have to merge all the lists, and every list has to be merged and merged again, so that each merge takes n operations. So we're splitting and then merging, so the final number of operations is n multiplied by the log of n. So it's a new big O value that we haven't come across before. It's called n times log n operations. So what do we know about n times log n? Well, log n is a lot smaller than n, isn't it? So n times log n is bigger than n because we're multiplying n by something. But it's a lot faster than the bubble sort, which is n times n, and the worst case for the insertion sort. So it's a new big O value. It's the first time we've come across it, and the value, the big O value, is n multiplied by log n. So the merge sort has got a big advantage over the other sorts that we've used so far. It's a lot faster. However, it does have a drawback. It uses up a lot of space in the computer's memory because of all this splitting down into smaller and smaller lists. So if we were discussing, pardon me, if we were discussing the merge sort, let's say in an exam, or if we're deciding whether we want to use the merge sort in one of our programs, we have to be aware that it uses up more space in memory than the other sorts. And if we had to write an evaluation, the advantage of the merge sort compared to the other sorts that we've looked at is it's much speedier, fewer operations. And the disadvantage is it uses more space in RAM, which might be an issue if we've got a very long list. What if somebody showed you some code and asked you, what do you think this code does? And how would you recognize the merge sort? Well, I think one immediate clue compared to the bubble or insertion sort is it uses two functions. It uses this other function called the merge function, and then it also has this splitting function. So the two things together make merge sort. It's often written using recursive algorithm. So like with a lot of the programs that we've been looking at over the weeks, we can write it using recursion or iteration. They're both fine ways of writing this program. We can write it as a function that returns a new list, or as a procedure that sorts the original list. And remember from the binary search that when we split, Python and many other languages have got a nice slice or split function that lets us make the list smaller and smaller. But we can always use left and right markers instead to do these actions, though I would say I think it's easier using split or slice commands. But in any case, we'll get on to writing the code next lesson. To recap what we've done this lesson, I've just briefly discussed how the merge sort works. So to remind you, split the list down into lots of little lists of 1, merge them to make lists of 2, merge them to make lists of 4, and so on until we get back to a full list. The advantage is it's fast. The disadvantage is that it uses up space in memory. The big O value is an unusual one, n times log n, and there are variations, though I'm going to concentrate on just one in the next presentation where we'll actually write it. And I'm leaving you with 4 questions to answer. So if you can write answers to these, then I think that shows that you've kind of really got the hang of the merge sort. Try and answer these without looking back at the video, but if you are stuck, you can go back, obviously rewind. What's the big O value and say why? Compare it, that means its advantages and disadvantages compared to the bubble and insertion sort. Say why it might be taken as an example of divide and conquer, and explain, and this one you won't find the answer to this in the presentation, you've got to think about it. How would you use parallel processing, concurrent processing to speed up the merge sort? Okay, so in the next lesson we're going to actually write the program to do the merge sort. So see you then. Bye for now.